Welcome to the video lecture series on testing of VLSI circuit. In this video lecture, we can see about bridging faults. Bridging fault or short fault is an unintended short or low resistance connection between two different nets in a digital circuit, causing the logic values to interfere. So it is not like stuck at fault, which is stuck either to ground or stuck either to VDD. It is like a connection between two different nets in a digital circuit. To explain this from the very basic, we have taken the small example as um, in our circuit which is shorted, A is connected to B, so A will be equivalent to B always. So fault free R will get 0 1 1 1, whereas A equal to B, so always A is going to be connected to B, so output is going to be 0 0 1 1. So there are two cases, the 50% probability of error. This may occur due to the manufacturing defects, dust or metal particles, or layout errors sometimes during the manufacturing. It is different from stuck-at fault. As I mentioned earlier, it is a short circuit between two nets, not to VDD or ground. It again causes the functional errors and increased power consumption at few cases. So this image presents how a manufacturing origin occurs. The metal particle causing a short between actually there is no short over here, but occurrence of metal may result in short between the two different nets. So this is how the error occurs during the manufacturing by metal particle or maybe unintended short or during the layout also the error may occur. So these were the causes of bridging fault. With the increase in the number of devices in the VLSI chips, the probability of short between the two or more signal lines is also significantly increasing because nowadays the number of connections are increasing enormously. So the occurrence of bridging faults occur, and there are different categories like input bridging, feedback bridging, non-feedback bridging, and all, which can be explained in the coming scenarios. Let us take this as scenario one, where in here, can you predict what type of bridging fault occurs? Input bridging occurs. It shorts certain number of primary input lines. Here, P1 to P5, it is. Let us assume that as primary input line. If it shorts, it may result in bridging faults. This is the first scenario. So this is shorted. Coming on to the scenario two, what is the type of bridging fault over here? It is a uh, um, feedback oriented bridging fault, but there is no feedback, that is output to input connection is no. So non feedback bridging fault, this we call it as non feedback bridging fault. Mm, this is feedback bridging fault. This comes under, in general, the bridging fault in positive logic is assumed to behave like a wired and bridging fault in the negative logic will be behaving like a wired or. So if bridging occurs between select lines in a circuit are considered, the number of single bridging faults alone will be n by s factorial, and the number of multiple bridging faults will be very much larger. So this happens in generally in a circuit. This is feedback bridging fault scenario. Here, due to this feedback, we all know that it is going to have memory, and due to this oscillation may also occur. So again, this is also a feedback bridging fault, where this may result in oscillations in the output. Coming on to scenario 4, this is nothing but you can understand this is an AND gate, sorry, an OR gate, A plus B, the whole. Previous lectures itself, I have explained you how to construct a CMOS gate. This is CMOS um, NOR circuit. This is CMOS NOR circuit. This is going to produce A plus B the whole bar, A plus B. So it is in parallel. Exactly the pull-up network will be series. So all those things I have already explained it. Now this is the layout diagram of the given NOR circuit. So these were the faults that are occurring. A is going to be due to the metal polysilicon chart. So the diagram is not clear, but in the book it is visible. So A is going to be the metal polysilicon chart. The C, which is occurring over here, CD, which is occurring over here, it is polysilicon N diffusion chart. CND, it is polysilicon N diffusion short, whereas E and F, if you zoom it, you can see E and F that is appearing. It is like a P diffusion sort. G, it is. Let us assume that it is a metal polysilicon short. So these shorts occur in the layout level and it may affect the circuit level also. So if you say A is grounded here, so which means that A is going to always get zero. So when zero means PMOS is going to get turned on. So always this is short. So the input A is not going to control the circuit. Instead, it is grounded. So this is how it affects the circuit. So these were the some of the bridging faults which we generally have to know. They are nothing but input bridging, feedback bridging, and non-feedback bridging. So this is non-feedback. This is feedback bridging. So input bridging we have seen in these cases. So I hope you got a basic overview about the different types of bridging faults. Thank you. Thank you for patient listening.